Okay, here we go. Let's learn about applying word problems. Rhiannon is here today. Thank you. Did you, okay, but did you, so you listened to the video. Star quality of organization. Way to go. Way to watch YouTube. What? Jared? Jared, dude, we missed you. Yeah, say something.
Hey, Jared, if you're listening to this, because you're probably not, but I'm gonna cut your hair when you get back. Okay, bye.
Oh, Jared, sorry, buddy. Okay, we're going to apply the ideas of maximum minimums to word problems. I know that you guys love word problems. It's something that you hope. You always ask the question, when will we use this, right? Well, here's a time where you could use it. So, farmer's making a pen out of 480 yards of fence. We're going to say it's a rectangular pen. He's going to be dividing the pen into 3 sections that are all equal in size. What dimension should he make the pen to maximize the area? Now, the truth of the matter is, when I used to do this type of problem, I wouldn't draw these 4 boxes. I would just grab a blank sheet of paper, and I would just start doing the problem. What I realized is that in my mind, I was organizing my thoughts, and that my students weren't necessarily thinking that same way. So you can do these problems however you want, but I'm telling you that in order for me to be an effective teacher, I needed to organize it by drawing 4 boxes. So if you ever need help with these problems, I'm going to draw 4 boxes right away to help you out. And in the first box, we model the problem. Okay? In the second box, we start to develop a formula or relationship. And the fact is we have to understand what is driving the problem. What's driving the problem is that we're maximizing the area. Maximizing the area. So what is the area of a rectangle? Length times width. Excellent. So I'm going to put those labels on my pen. I've got width, 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 length, and length. Now, the goal is to have the largest area possible. This is good for the farmer. That way, there's more resources for the cattle to be able to eat. There's more space for them to be able to move around. However, I can't make it 2 miles by 3 miles. I don't have that much fencing. So I need a second equation. I also know I need a second equation because right now I have 2 variables. I have length and width. I only want 1. In order to pare this down to 1 variable, I'm going to need a second equation. Does somebody know how I can use a restriction here to come up with a secondary equation? Yo, Nemec. Okay, good idea. We're going to assume not less than, we're going to assume equal to, that we are going to use actually all of the fencing. And we don't just have 1 length and 1 width. How many lengths do we have? We have 2 lengths and we have 4 widths. So as I piece it together, I see that this is going to help me out. Now, I can choose to either solve for L or solve for W. It will work either way. What would you like to solve for? Excellent. So we got 480 minus 4W is equal to 2L. Then I divide through by 2, and I get 240 minus 2W is equal to L. Now I could take this and plug it in right there. That will then generate my equation. This is kind of my scratch work area. This is really the aha moment where the magic happens. Everybody can figure this part out, and this part, and this part. Boxes 1, 3, and 4, nobody has a problem with. Box 2, that's where you see what kind of mathematician you are. Okay? So I now have area, and I'm going to write it as a function. What is the variable that's going to be in this equation? W is in, so its area in terms of W is equal to, I have the quantity 240 minus 2W times W. Or area in terms of width is equal to 240W minus 2W squared. I would like to solve that. What am I trying to solve? I'm trying to do what to the area? Maximize it. What shape does that make if I graph it? Right side up or upside down? Does it have a maximum? It sure does. And so you can see that by writing the proper equation, it models it for me in a way that is going to give me a nice solution. The x value is going to be width, and the y value will be area. A lot of people think that the y value is going to be length. No, your function says area in terms of width. That's what you've written. So, what point tells me the maximum? The vertex. I know how to find the vertex. My wonderful teacher gave me 2 worksheets to practice doing that. So, I have 2 formulas. What formula should I use here? Yes. We're just going to put it, yes, you could do vertex form. I would rather just do this because negative b is going to be negative 240, and twice negative 2 is going to be negative 4. I divide that and I get 60. So 60 is going to be what? What does that represent? X value, which is the width. So let's answer the question. The question says, what dimension should he make the pen? Well, I know it should be 60 yards by, how do I figure out the length then? You can find the area and then divide by 60, or you could go to an equation that you've already created. Whoop. I know it's math. It's hard to hold back. I got 240 minus 2w is L. So I can just plug it in there. If w is 60, then I get 120. Have I answered have I determined what the actual maximum area is? No, the question's not asking for that. If I want to know maximum area, I could do one of 2 things. I could take this 60 and plug it in, and that would tell me the area. Or I could take my end result, multiply those together, and I would get the area that way. Okay? See that? See the organization? This is very definitive. This is very definitive. So is this. This, a little bit more free-flowing in scratch work. This is just the way that I feel is most efficient to teach it. If you got a different way of doing it, go ahead. It's free country. So, what we're going to do now for these 4 problems is we're not going to actually solve for anything. We're not going to find a maximum area. We're not going to find a minimum cost. We are going to practice what happens in box number 2. So it says the sum of 2 numbers is 24. Find a function that models their product in terms of x, one of the numbers. So if I want to write an expression for 2 numbers that sum to 24, I write. But what's driving the problem is a product of those 2 numbers. How would I write the product of x and y? Product is equal to x times y. It says that it doesn't want 2 variables, it wants 1. So how could I get rid of y? Y is equal to 24 minus x. So now I can state that the product in terms of what variable? X is equal to x times 24 minus x. That's an expression for the product of 2 numbers whose sum is 24. And instead of using 2 variables, it's 1. Again, we're not solving for what the maximum product is or anything like that. We're just writing it because we need to practice that kind of box 2 spot. You try B on your own. Then we'll do C together, then you'll do D on your own. Show me you got some smarts. Area is equal to length times width. I know that the length is 8 more than the width. So area in terms of width is 8 plus W times W, or 8W plus W squared. So yeah, if you did, thank you for saying that. So a length minus 8 is equal to W. So you could have area in terms of length is equal to length times length minus 8. I think some people did that last hour, and I didn't understand. They never said that. Like, oh, I got it wrong. No, it's right. It's just there's two ways to express it. Oh, it does say. Okay. Well, I just want you to know that it does say that, but in terms of the problem, you would be able to get the right answer either way. Either one will give you the right answer. It's just in this one, like the last one we came up with 60 and 120, right? We came up with 60 first. In this one, you come up with 120. And you go back, you get 60. That's the only difference. Okay? So, all right, we'll try next one together. Rectangle has an area of 40. Okay, I got a rectangle, 40. I'm going to put that in the middle. I got width. I got length. Says find the function models its perimeter. Oh, gosh, perimeter. What's perimeter? 2W plus 2L. So, it says the length of one of its sides. So I can have either W or L. Doesn't matter, right? Okay, one of the sides. Well, I need a second equation here. What's my second equation? So I'm going to divide both sides by W, and I get L is equal to 40 over W. So now I can take that and plug it in for L. P of W is equal to 2W plus 80 over W. So again, these are kind of those aha moments that you need to come up with. Try next one on your own. Okay, I got a rectangular box. The base is square. So I'm going to call the base x by x. It says the height is 3 times the depth. So what would be the expression for the height? 3x. Now, in order to find volume of a box, I just multiply all three dimensions, right? So the volume in terms of x is 3x cubed when you multiply all those together. Again, I'm going to try to show you as many examples. At some time, we hope the aha moment comes on your own. Flip it over. We're going to skip problem 3. We will do problem 4 today, and we will call it good at that. Tomorrow we'll do 5, 6, 7, and 8, okay? You'll see a little bit different examples. But we're going to go back to a problem very similar to what we had before. Farmer is building a barn or building a fence, and this time he's building it up against a barn. That way he doesn't have to use fencing for one of the sides. Pretty smart, huh? So I've drawn the basic model. You tell me where to go. Area, length times width. Let's put some labels here. Width, length. Okay. Now I'll use the 320. Great. Four. Okay. Okay, I see A, that's fine, but I want to be A of W. Thank you. I want to be very specific that I want a function notation. Why? Because everybody always wonders when they get their answer, what does the answer represent? Well, if your x variable was W, then it's width. I mean, this is the language that we're using. It's important. Equals what? Okay, so it's a parabola. It's upside down, right? Okay. Okay, so the vertex, you're looking for that. What is negative b? What does 80 represent? The width. Because, remember, your vertex will give you an x value, in this case is w, and then the y value will be a of w. So the y value would give you the area, the x value gives you the width. That's what we're finding. So I have 80 what? 80 feet by, what are you doing, Braden? Back into where? Okay, so this tells me, it spells it out. You're wondering what the length is? It says, it's speaking to you. I am the length. I am 320 minus twice the width. Okay? All right, since you guys are extremely intelligent, we got done earlier than the other class. Now, this assignment is a little bit different. You get to choose 5. Now, some people want to do all 9 or 10 because they want to feel really, really well prepared. But you're not going to be able to do all 5 problems necessarily today because we still need to do more examples tomorrow. But out of this group, you might find a few that you're capable of doing, especially early on. Just note that for, say, problem 23, it divides it up into 3 parts, A, B, and C. Don't worry about the directions for A, B, and C. Just solve it the way that we did, and you should be good. My true intention is to rewrite this assignment in a worksheet format, but as you can see, my time got taken up by doing these 2 in worksheet format as opposed to the book. So I'm a little bit late on this one, but haven't had my prep this week either. So, well, I'll get out the book right now, and I'll tell you the ones I think you could solve. How's that? No, you in the end will just choose 5, but I think to really feel confident, I would